Hello everyone, welcome to this series of update webinars on the Oasys LS-DYNA Environment software. As you will know if you've dialed into the previous ones, these 4 webinars detail the recent LS-DYNA updates and the latest features in Oasys 17, which is now available to download from our website. We'd usually provide this information at the user meetings we hold in various regions, but due to current circumstances, that is not possible. Although the events have been postponed, we wanted to get these latest updates to you to ensure you know what exciting new features and updates are available to you in the latest versions of the software. The webinar series kicked off on the 6th of May with an update on the LS-DYNA software. Our project manager, Jamie Talbot, also gave us a general update about how we're supporting those of you working from home, the acquisition of LST, and our software team here at Arup. If you didn't manage to catch the webinar, the videos are available on our website, and I'd recommend you watch if you can. So the remainder of our webinar program looks like this. If you didn't catch the previous Oasys talk, you may notice a difference with the Oasys theme talks. As the Oasys Suite continues to become more integrated, many of the new features and enhancements benefit the whole LS-DYNA workflow rather than the individual products. For this reason, we've moved away from the pre- and post-processing theme demonstrations to how the new features and enhancements aid the whole workflow. Throughout these Oasys Update webinars, you'll notice the new user interface launched with Oasys Suite 17. We're pleased that this has been so well received by those that have used it. If you want to find out a bit more about what's changed and why, just visit this page on our website where you'll find a short introductory video, some slides, and a frequently asked questions document. So, my colleague Alistair Parks and I are going to kick off with the second of our Oasys talks, accelerating your workflow. So, I'm going to start by talking about accessing and writing data. So model read-write speeds are increasingly important as model size and model complexity increases. And the Oasys Suite constantly develops to improve speed and performance in handling these large amounts of data. And Oasys 17 further improvements have been made in this area. Here we're showing read and write speeds across the last few releases of Oasys Primer. Now this is reading and writing ASCII keyword data. So this is in LS-DYNA keyword format. As you can see with reading, we've made significant gains over the past few releases. We're now just over twice as fast as we were a few releases ago. But you can also see that we've made significant gains in writing speed as well. Now we're around about 5 times as fast as we were in version 14. I just wanted to highlight the gains that we've made between version 16 and version 17. You should see significant improvement in write speeds in version 17 compared to version 16. So the previous slide showed timings for reading and writing of standard ASCII keyword data. But Primer also has the ability to write a binary file format without loss of data. And this has the advantage of being a much smaller file size and allowing even faster read and write times. So let's go back to the previous chart. And let's add on the read and write times for a binary format file in Primer 17. As you can see in reading the file, it is faster, you get modest gains, but it's writing a file where you gain significant speed improvements. So using a binary file format is a really useful way of saving time during your model development.
Now that Gavin has talked about reading and writing from Primer, I'm going to cover the speed improvements we've made to D3plot. We've made use of parallel processing in more of our contour plotting and animation routines. So for large models containing mostly shells, you should see a speed increase of up to 3 times when doing shaded image or continuous tone contour plotting, and for animation playback. And this will be especially the case when some elements are blanked or when cut sections are on. For large models containing mostly solids, the speed increase will be up to 5 times. When elements are blanked or unblanked, D3plot has to recalculate the contour bar min-max values, and now you'll see a speed increase of 4 times or more. But it's worth noting that the overall time to plot results and to build animations may still be dominated by reading data from disk, especially over a network drive. Predictive picking in Quick Pick is now 4 to 5 times faster, and when sketching an entity, we've removed some of the unnecessary recalculations to give you a smoother experience. D3plot used to perform slower if there were 2 models in the same window. There's now no slowdown with multiple models in the same window compared to the same models being in different windows.
Okay, so I'm going to talk about primer checking now and how you can now save and compare check status. So often the workflow on building, modifying and checking models is as follows. So you've got your initial model has been created, you run a model check and you fix some issues that you have in your model. And that would lead to your baseline. Now you may have some acceptable warnings in that baseline. So you might run a model check on your baseline and it comes up with some warnings that you have, and you might be happy with the warnings that are in there. Now there are ways in Primer that you can demote those warnings so that you don't see them again, but let's say you still see them. Now from that baseline you now do some design studies and you run a model check on those design studies. So how do the check results of these studies compare to the check results of the baseline? What has changed? So it's useful to know what has changed between your baseline check status and your design study check status. So what issues do we currently have with that process? So Primer has a comprehensive checking capability, but on a large complex model, repeated check operations can take some time. Some reported errors and warnings may be deemed acceptable to the analyst. So how do you record that status? And it's difficult to compare the check status between multiple models at the moment. Picking up on the first point on that previous slide, one thing we have done in version 17 is to improve the time it takes to check connections within your model. So one thing that can lead to longer checking times is a large model containing many connections that are attached via tied contacts. So you have to check that those tied contacts do indeed tie and there's not some problems with constraint clashes or maybe the items being too far away from the panel. So Oasys 17 has improved the performance of contact check handling within those connections. So this benefits model connection checking, setting up of the connection table, and remaking connections. So speed improvements can obviously vary between models and the contents of those models, but a speed up of up to 50% on connection checking can be seen. Moving on to some new features we've added into Oasys 17 that allow you to compare checks across 2 models. So a model can now be checked against a reference model, and 2 check trees are displayed. So in Primer, you could read in 2 models, run a check on both of those models, and then look at the differences between the check status of those 2 models. And when you're looking at those trees, you can just look at the differences between those trees as well. So this is useful for the workflow that I was mentioning before. You can read in your baseline, you can read in your design study, run checks on those 2 models, and then look at the differences between the 2 check status. Now obviously reading in your baseline every time and running a model check on it is not ideal. It could be quite a big model and you don't necessarily want to be able to run the same model check on it every single time. So we've added the ability to check against a reference file. So as I've said, this is useful for working with large models. So if you read your baseline in, you can run a model check, and then you can write the status of that check as an XML file and save that as a reference file. This means when you read in future models, you can directly reference that XML file and compare the check status of your current model against that reference model without having to run a potentially time-consuming model check on that reference model again. Okay, so I'll just demo some of this so you can see how it works in practice. So here we've read a model into Primer, a vehicle model, and I'm going to run a model check on this model. Now this is a reasonably big model, so it'll take a few seconds to run through. Now let's say this is the design study model that I mentioned earlier in the workflow. And we're running through looking at what the errors and warnings are for this particular model. So we'll get the check tree here. Here we go, this is the check tree and all the errors and warnings that Primer has found. Now if you close down this check tree now and the check information, if I just move the model around, maybe blank a few items, but don't change any data in the model, if I now click apply, the check tree will appear instantaneously. That's because in version 17, Primer will remember check status and it knows when you've changed data in the model. Now down the bottom right here, you can see the new options for specifying a reference file so that you can run a model check on two models and compare the check status. But here, I can also show you how I can write out the XML file of this check tree. So if I write that out, I can store that information in the XML file and retrieve it later on to compare against a new model. So I'm going to do that now. If I select reference file on the bottom right, and I can select an XML file for the baseline model, and then click apply, and it will compare the check status of the baseline, which is written in the XML file, which is instantly available, and the current check status of the model I've read in, which is my design study. So on the left-hand side, we have the current model, a design study, and the right-hand side, the check status from the XML file. The highlighted ones are the differences, the new errors and warnings that I have in my current model. If I click on diff only, you just see those new errors and warnings. So now I can investigate all the new errors and warnings that have been introduced into my design study compared to the baseline check status. So this is a really useful tool to help speed up the process that I explained earlier, that workflow process of creating a baseline and also creating design studies and comparing the check status between the two. And now I'm going to talk about some of the morphing improvements you'll see in Oasys 17. So morphing capabilities in Primer have increased in the last few releases. We have the ability to create simple or complex morph boxes surrounding mesh and then interactively morph the mesh inside those boxes. The ability to work in global or local coordinate systems. Various morphing interpolation options. It can be driven via scripting using the Primer JavaScript API and can also be linked to LS-Opt. Now further improvements have been made to Oasys 17 to make it faster and easier to morph entities in your models. One of the new features we've added relates to connections. So connections can now be automatically repositioned when you morph panels. So Primer will automatically find connections associated with morphed mesh and gives you the options to view those connections in the connections table, or you can automatically remake them using the remake button on the morph panel. In version 16, we introduced higher order morph boxes, which allowed you to create morph boxes with lots of control points to give you greater control over the shape of the mesh when morphing. We've now added a new switch that allows you to switch between higher order or multiple linear morph boxes when creating multiple control points. With the multiple linear option, the morph boxes share morph points in between. You're essentially creating multiple single order morph boxes joined together. So although the initial configuration of adjacent linear boxes looks very similar to a higher order box, the behavior on the morphing is very different. So here we can see the difference between a higher order box and multiple linear boxes joined together. At the top, is the high order box, and you can see that when morphing the mesh, the nodes do not follow the morph points exactly. However, with multiple linear boxes, the nodes do follow the morph points exactly. So depending on what you want to do with morphing, you may want to use a higher order box, or you may want to use multiple linear boxes. But the option is there now for you to be able to create both very easily. Some other general improvements. There have been some speed improvements when morphing, and it's now significantly faster to create morph boxes and morph entities on large models. Also, when you want to select multiple drag handles to morph, you can now select those multiple drag handles by area rather than selecting them one by one. I'll now show you a demo of some of the things we've just discussed. So in this example, at the top, we have 3 linear boxes joined together. At the bottom, we have 1 higher order box. I'm going to morph these to show you the difference. So in the Create panel for morphing, this is where you set the option for these 2 types. So if I go to Morph and turn on Edge and Face drag handles, I'm going to morph these boxes by clicking on the Face drag handle. So if I drag this up here, drag the bottom one up as well, you can see that with the linear boxes joined together, you have more localized morphing and get sharper bend at the transition between the morph boxes, as opposed to the smooth curves in the higher order box. So both these options are now available when creating morph boxes. So you can choose the option that you need for the type of morphing that you want to do. In this example, I'm going to show you how in Primer 17, you automatically update connections when morphing. So here we have the sign of a vehicle, and we're going to concentrate on the B pillar. If I turn on connection entities, you can see I have some adhesive, I have some spot welds. At the top of the B pillar, I have a single heat affected zone remeshed spot weld. So if I go to Mesh Tools and Morph, I'm going to create a higher order box in a local coordinate system, which I already have created in the model. And I'm going to create 6 points in the local X direction and 2 in the other directions. And I'm going to create those boxes around a node set that I've already specified in this model, which are the nodes in the B pillar. So you can see now I have a higher order box around the B pillar that I can use to morph the mesh. So in previous versions to Oasys 17, you couldn't morph the mesh connections. So let me turn this off now, and I'm going to morph the mesh. Now, as you can see, the connections are being left behind. So this is how it worked in Oasys 16. The adhesive is left behind and the spot weld is left behind. So if I undo this morphing and turn on the new option to also morph connections, and now repeat the morphing operation, you can now see that as I'm morphing the mesh, the spot welds and adhesive are being updated. Now, when I'm doing this, the underlying FE entities, so the solids in the adhesive and the spot welds, are also being morphed. So what I might want to do after morphing the mesh and the connections is remake the connections according to the original recipe, so the width of the adhesive or the diameter of the spot weld. So here I'm looking at the connections table of all the connections that have been identified. But if I click on remake, it will remake all of those connections to the original recipe. And if I zoom in now, you can see that the heat affected zone is no longer skewed because of the morphed mesh. So this is a really useful tool that allows you to automatically identify the connections associated with the mesh that you're morphing. And Primer will then give you the opportunity to remake those connections, and their locations will have been automatically updated in the morphing process. I'm just going to talk about a small feature that we've added to database cross-section creation, which will hopefully make it much quicker to create database cross-sections. So what we've added is an option to the creation panel for database cross-sections to auto-size the plane so that it's centered on the cut elements and the len L and len M dimensions are minimized so that it's just encompassing the cut elements. And I'll show you a demonstration of this. If we go into Primer, and what we're going to do is just look at the two outer parts of this lower rail. And I want to create some database cross-sections through this. So I go to the cross-section creation panel. I'm just going to select a part set, which contains these two parts. So it's just these shells on the screen that I'm going to cut through. Now, if I click on the shells, it will show me the database cross-section that's going to be created. It's centered on where I clicked, and len L and len M has been set to encompass all the shells. But as you can see, it's quite big because of where it's centered. So I have to come in and drag the size down if I wanted to make it look more reasonable for the shells that I want to cut through. So I created it there. But what we've added is this auto size plane option. So if I turn that on and now click on the shells, you can see the center is now the center of the cut shells, and len L and len M has been set to just encompass the shells that are cut in that part set. So now I can quite easily create lots of database cross sections that are just the right size to cut through the shells that are selected in the part set. So now to talk about the new scripting capabilities across the suite. So the advantages of writing a JavaScript in the Oasys suite is to create new capabilities. So you can easily write your own custom script, for example, to detect specific problems and errors. Scripts can be run as part of an automated process, for example, running checks as part of a job submission process. And you can keep your application completely confidential. So some example applications in Primer are maybe creating a simple mesh or test models with standard loading, data checking or correcting, file format translators. So a good example here is special formats, spot weld or connection files, or automating routine tasks. In THIS, you can do things like automated data quality checking across many output curves, or maybe displaying data for parts in different ID ranges on separate graphs. And the classic example in D3 plot is generating your own data components for plotting, calculated from any information already contained in the model or from external files. So first, I want to talk about some of the additions we've made to the Seatbelt class in the Primer API. So the belt class has existed for a while in the Primer API, but for version 17, it's been extended to make it possible to drive all the functionality of the Primer Seatbelt tool through JavaScript. So as well as extending the constructor to help create the belt definition, we've added the following methods as well. So insert point adds points anywhere along the belt path. Fit fits the belt around the occupant or seat. Generate uses properties from an existing mesh if one exists, and regenerates or creates a new default mesh if it doesn't exist in the first place. GetMesh retrieves mesh segment properties so you can investigate what your belt is made from. And SetMesh modifies some mesh segment properties and regenerates the mesh. So using these new additions, it's now possible to create a fully functional belt or modify an existing belt in your model to fit it and to regenerate the belt mesh. So here we have an example of a process flow where you're creating a belt path and belt through JavaScript. So the first stage is the constructor, where we define the belt definition. We then create path points for the belt path using setPoint or insertPoint. We then fit that belt around the occupant in the seat. We generate the mesh, and that creates the belt. We then might want to use getMesh to inspect the mesh, and then we might want to, using that information, modify the mesh. We might want to change it slightly. So all this is now possible using the JavaScript API. So I'll just show you a demo of this. Okay, so here we have an example model. We have an occupant sitting in the seat, and we don't have a belt definition at the minute. So I'm going to go to script. I'm going to run a script called belt fit generate that we've created that will use these new JavaScript API hooks to create a belt path, a definition, a belt path, fit it, and generate the mesh. So if I click run here, as you can see, it's created the belt path points. It's now fitting around the occupant and the seat, and it's generating the mesh. Here you can see the mesh has been generated. This seatbelt is a mixture of 1D seatbelt elements and fabric shells. So the additions that we've made to the API that allow you to do this through a script is that we, in 17, we support additional belt properties that allows you to change the properties and achieve the belt fit that you see here. 17 can do the actual fit through the API, which it couldn't before. And 17 can generate the mesh, which it couldn't before in the API. And also 17 allows you to insert a path point anywhere, which you couldn't do before with the API. Now let's say you want to then modify this mesh using the API. So if I zoom in here, maybe we want to change the number of 1D belt elements at the end. I've got another script here. If I change to that, this is a script that queries the belt mesh and then changes it. So if I run this, hopefully you could see that we've changed the number of 1D seatbelt elements along this stretch of the belt path. So as well as being able to create a belt mesh and fit it and generate the mesh, you can then also query that mesh and change it again. So these new API additions allow you to easily create and fit from scratch multiple belt definitions, integrate belt creation and fitting into an automatic process. It allows you to ensure consistency in the creation of belts. And quite powerfully, it allows you to create multiple robustness designer experiments analysis with different belt, seat, and occupant positions and seatbelt properties. Okay, so I just wanted to mention one other addition we've made to the seatbelt tool in Primer while we're here. We've added a new button in the menu where you specify path points for your belt, where you can read a CSV file to read in path point locations, and it will populate the list of path points automatically. So it's an easy way for you to bring in path coordinate points. Perhaps these are points from a test measurement, and you can bring those in and automatically create path points for your belt definition from the information in the CSV file. And the CSV file just needs to contain XYZ coordinates really, but there are other things you can specify in there, like a node ID, what type of point it is, maybe it's a retractor, maybe it's a slip ring, and so on. So you can populate that with lots of different things if you want, but it really just needs the XYZ coordinate. So this is another way that you can more quickly populate and set up the path points for seatbelt definition. So let's talk about some other additions that we've made to the APIs. So I'm not going to go through all the changes we've made to the API because there are many of them. But please refer to the API manuals and the What's New PDFs for more details on what we've added. But here are some of the highlights. We've added the ability in the Primer API to check how many flags are being used, so you can make sure you have enough flags for the functionality that you're trying to add in your script. There's a new slider widget for GUIs. We've added support for defined function in Primer API. We've added more functions to set up and modify mechanisms in the Primer API. We now have access to model output settings, so ASCII output, binary, compressed, uncompressed, etc. in Primer. We also have access to new equation functionality in THIS. And we've also got access to a new page constructor in the Reporter API. So that's just a few things that we've added, but we've added a lot more. So please do have a look at the What's New PDFs to see the details. So just a note about writing scripts. So writing scripts can be time consuming because you have to refer to the APIs and remember what arguments are applicable to particular functions that you're using. So it can be frustrating to refer back and forward. So one way to speed up the writing of these scripts is to use software that provides information as you write the script. So it gives you information about the functions that are available, what the argument should be, and so on, directly from within the script. So one program that does this is Visual Studio Code, which is produced by Microsoft and is free to use. And that uses something called IntelliSense to list objects, functions, and parameters as you type. So as you can see here is an example of typing a function. It tells you a list of all the properties that are available and so on. You can easily, it makes it much quicker to add functions into your script. So in the standard Oasys 17 release, you'll find IntelliSense files in the Oasys 17 IntelliSense directory in the release package. And we've added them to allow you to use IntelliSense for all the APIs of the Oasys Suite. So previously this was just available for the Primer and THIS APIs, but now it's available for D3plot and Reporter as well. Now there's a document in that area that gives you full instructions on how to install Visual Studio Code and set up the files to use the IntelliSense to make it much easier to write scripts in our software. One other point to note is the layout of the JavaScript API section of the manual for D3plot has been updated, so it's now more like Primer, THIS, and Reporter, and much easier to navigate. So the majority of the D3plot functions are in the global scope, but to make them easier to locate, they're presented in different categories in the navigation tree now. And these are followed by sections for classes shared with Primer, like the widget class and the window class and so on. And the D3plot global functions are also listed in alphabetical order in the global class section, which makes it easier to find the functions that you want to use. Finally, with scripting, I want to mention a custom tool button. So a custom tool button can be added to enable you to easily find and run your own scripts. It's controlled by two preferences: custom tool name, which defines the name you want to appear on the button, and custom tools script directory, which specifies the location of the scripts you want to link to that button. If the preference exists, Primer will create a button next to the Quick Find tool, as shown in the image at the bottom here. So Primer will search the directory that's specified in the preference for scripts and display them in a pop-up menu on the button. So here's an example: Primer custom tools name Arab and Primer custom tools script directory, the location of the script. So note that these preferences could be defined in your company-wide central OAPref file so that everyone will see this button and have access to your scripts. So just to show you this in Primer. So here we have a Primer session with the same model I was showing before. And as you can see, I now have an Arab button next to the Quick Find button. If I right click on that button, I have access to a few scripts that I've set up in the specified area. And I can click on any one of these scripts to run it. So now I'm going to talk to you about some of the new features we've added into the Oasys shell for version 17. First of all, the new look. As with the rest of the programs in the Oasys suite, the shell has also been refreshed and has a new UI. As you can see, it now has a landscape mode. All the same functionality is in there. You can access Primer D3 Plot THIS Reporter and also access the LS-DYNA submission panel. All the options and batch options are available in the buttons below the program buttons. You also have access to the utilities, preferences, manuals, and themes as well through the shell. The new themes pop-up allows you to change the GUI across the entire suite to all the various different new themes, dark, light, and classic. And the manuals pop-up has now been redesigned to give you easier access to the PDF and HTML formats of the manuals. Also, you can access the What's New presentations for all programs from this menu. So that contains much more information on all the new features that we've added in across the suite. Moving on now to the LS-DYNA Submission Options panel. In previous versions of the shell, when you specify what version of LS-DYNA you want to run in, you have to specify all the versions in a file called the DYNA versions file. Then you can access those versions in a drop-down list through the LS-DYNA Submissions panel. Now you can also specify an executable, an LS-DYNA executable, directly from within the shell submission panel. Also, when specifying that executable, you can easily add that to your DYNA versions file, which means you'll have direct access to that executable from within the shell via a drop-down from that point onwards. Note that this option is also available in the command line version of the shell. We've also updated the input and output options on the additional files panel. As well as this, we've also updated all the sensor switch kill options. Note that all of these options are also available from the command line shell version as well. I'd like to just mention checkpoint files as well. Checkpoint files are command files that are automatically recorded when you use the Oasys software. These can be replayed when you open the software. Now, previously, you would, by default, get a panel that opens up when you open up Primer D3 Plot THIS that gives you the option to replay previous checkpoint files. By default now, you won't see that, but if you want to turn it on again, you can do so through the Options panel in the shell. I'll just briefly mention the ZTF options. A ZTF file is a file that is written by Primer and can pass model information to D3plot and THIS to aid post-processing. In version 17, specific ZTF categories can now be selected or deselected when ZTF files are written. Primer can be instructed to manually write ZTF files from two possible locations: in the Options tab during Model Write or from the Model Utilities menu. These new options allow you to have control over both the size and the contents of the ZTF file.
A big part of accelerating your workflow is automation, and we're seeing more and more of our users turn to Reporter for automating tasks. In the previous webinar, I introduced the new integrated Reporter workflow, which allows you to capture results directly from D3plot and THIS into your reports. Gavin also showed you the new user interface that we've added for all of the programs. In this webinar, I'm going to show you the extra steps we've taken in Reporter to make it easier to use and quicker to get started with, so that you can start using Reporter with your team. When you start Reporter 17, you'll see that we've added a new window to help you choose a template. There's a list of your recent files on the left, and you can select from the list and click OK to open, or just double-click to open a file. Now that the template is open, you'll see that we made lots of changes to the main window. But before we take a look at those, I want to talk about the new library features. So I'm going to go back to File, Open Library Template, and we're back in the Startup window. On the right, you can choose one of the library templates that we've added to make it easier to get started with Reporter. The library templates are split up into tabs. In the Standard tab, we have various standard layouts to help you arrange your content. And in the General and Automotive tabs is where you'll find the library templates we provide for the various crash test regulations. To help you navigate the library templates, as well as the tabs, you can filter by category So on the Automotive tab, you could filter by regulation, impactor, or year. And on the Standard tab, you can select from a number of different themes, as well as filtering by page size and orientation and layout. For this demo, I'm going to choose the Sky theme, filter by title page, and then pick the widescreen PowerPoint layout. Now that we've chosen a template, let's take a look at the rest of the main window. We've modernized the icons of the tools on the left and split them up into various different categories to make them easier to find. If you're struggling to tell one from the other, you can now show labels, and you can also group the tools together. Tool selection then works as before. We've also added some toolbars along the top. There's the View Page Master button that allows you to switch between master and normal view. There's the Generate toolbar that allows you to generate the report, or the current page, or the currently selected items. And there's the Page toolbar. If I click the Add Page button, then I can add a page based on the template's theme. And actually, I'm going to add a whole bunch of pages now, probably one of each layout type. So we can also delete pages or duplicate the current page. And in Reporter, you've always been able to change page by using the scroll wheel on your mouse, but now we've added these page navigation buttons to make it a bit easier to change page. And finally, we have the Oasys toolbar, which allows you to launch D3plot and THIS in the link mode that I demonstrated in the previous webinar. Back in Reporter, you'll see that we've added these item attributes toolbars on the right. Previously, in order to edit an item's attributes, you'd either have to double click on it or right click on it depending on the action. But now we've exposed these attributes in the main window to make them easier to access. So for example, if an item is out of position, then you used to be able to right click to align the items. Now as well, you can use the align buttons to align the items how you want. You can also edit multiple items at a time. So for example, I could edit the width of all of these items at once, or I could edit the captions and, for example, change their color to match the theme color, and use the font options to change the font size or the font style. You'll also notice that we have these placeholder items in Reporter 17. And in the previous webinar, I showed you how to capture items directly from D3plot into Reporter. But placeholder items aren't just limited to D3plot and THIS. You can convert them to any type of item you want. I can double click on the item and convert it into, say, an ellipse. And in fact, you can now convert any item into any other type of item by right clicking on it, going convert into. Here I'm going to convert this back to a text box. So this could be useful if you want to use the standard layouts to mix your content from D3plot and THIS with other text and images. Once you've created some Reporter templates of your own, you probably want somewhere sensible to store them. If we go back to File, Open Library Template, then we can add a library to Reporter here. As you'll see in the description here, it says that Reporter will search all of the directories listed here for library templates, pages, and scripts. And it's important that the directory you set up has subdirectories named templates, pages, and scripts in order for Reporter to find those items. So for this example, I'm going to choose the library we've set up at Arup to store our templates. You'll see inside we've got subfolders called templates and pages for storing all of the templates and pages that we've set up. So if I select the Arup library folder, then the next time we start Reporter, all of those templates will appear in the startup window. Now I've just made this setting for me. If you wanted to set this for everyone in your team, then you would need to edit the OA pref file in your admin or installation areas. So if I click OK, Reporter will tell me that any newly added directories will be scanned the next time I open Reporter. So I'm going to close Reporter now. And then if we start Reporter again, then now you'll see that there's a new Arup tab that's appeared. So now I can choose from any of the standard Arup reports. And in fact, there are some that you might even recognize. So how did the ARUP tab actually appear? Well, for each template, there are template properties, and this is the information that appears in the startup window. So we've got a title and a description for our template, and then we can tag the template with any number of different categories. So here we've got the theme and the type of the template, and it's this type which determines which tab it appears in. You can also set the thumbnail for the template, either generated automatically from the first page, or you can embed an image from a file. And finally, it's worth mentioning that we've improved reporter preferences. You can now access most of reporter preferences from the File Preferences menu, where you can control various editing and grid line settings, set the default file name convention for your models, and change the GUI theme. And you can now save most of the reporter preferences directly from Reporter, rather than having to edit the OA pref file or use one of the other programs. We hope that all of these new features make it easier for you to use Reporter, customize it to suit the needs of your team, and help start accelerating your workflow. Now I'd like to talk about some improvements we've made specifically to accelerate the Automotive library template setup. But we've actually noticed an issue with the version 17.0 release. So in order to get this feature to work, you need to set a preference so that Reporter starts in the right directory. Now, this is one of the preferences you can't actually set from Reporter, but you can set from any of the other programs. So I'm going to set it from Shell. If I click on Preferences and then choose Reporter and Start In, make the preference active, and then I just need to set the starting directory to somewhere that I have write permissions. So this could be my Documents area, or on Windows, my User Profile area. Then I save the preference and we'll be ready to go. For more information about the issue and the workaround, read the news section on our website. The most time-consuming element of using one of the Automotive library templates is setting up for the first time. So if I select the EuroNCAP FFB template, then the first thing it will do is prompt me to open the keyword file of the job that I want to process. So once I've selected the keyword file, then a message will appear telling me that in order to extract the required data, the template requires some information, and this can be stored as post-RN data, but it can't find that. So it's asking me if I've already saved that data to a CSV file. If we're setting this up for the first time, then I haven't. So I'll click no, and then Primer will start so that I can select the required information. So Primer reads the keyword file, and then a window appears showing all the information I need to enter. Now, previously, you would have to enter all of these inputs one by one, but in Oasys 17, we've added some features to make this quicker. At the top, you select the dummy model you're using. Now, previously, we only used to support Humanetics dummies, but we now support LSTC dummies too, as well as ARUP, Cellbond, and Dynamo dummies. For a full list of the dummies we currently support, you can look in the Reporter Library Templates Dummy Info folder in your installation. And if your organization uses dummy models that we don't currently support, please do get in touch with us so that we can add the support. So my model uses LSTC dummies, so I'm going to pick the LSTC Hybrid 3 5th percentile version 2 dummy. And you'll see that when I do that, then it automatically populates all of the inputs with the default dummy IDs. So I don't need to do it myself. I can do the same for the passenger dummies. But now all my dummies are actually pointing at the same set of IDs, so they're all pointing to one dummy in my model. So you can add the offset for the dummy ID, click Import IDs from CSV file with offset, and then an offset is applied to all of the IDs. Now I've just picked 1, 2, 3, 4, 5 as the offset, so it's now showing that all of these IDs are invalid. So we need to make sure we pick the correct offset for our dummy. To do that, we can collapse this window and then open the include tree. If I go down to the passenger dummy, I can see that it's an include transform. So if I right click on it and go transform edit, then I can see the offset used for the passenger dummy. If I take a copy of that and then go back to the window, then I can enter the correct offset, import again, and all of the IDs are now valid. So this has saved me a lot of time in the setup. The only inputs that I need to specify are the other inputs that don't relate to dummies. So for this test, it's the steering column intrusion springs. I've set these up earlier, so I'm just going to pick them from the database history. And then we'll be ready to save as a CSV file and continue with the template. It now asks me to select a directory containing the analysis results, which for some people is different from the location of the keyword file. And then to select a directory to write images or curves to. Again, for some people, it's convenient to be able to choose a separate directory for output images. Now I've set up the template, Reporter launches TIAS to complete the generation. So hopefully the default dummy ID feature makes it that little bit easier to get started with automotive library templates. And as always, if there are any dummy models or crash test regulations you would like to see added to Reporter, please do get in touch.
Thanks for that, Alistair. So for those that didn't catch the last webinar, I just want to let you know about the new features information available on the website. These PDFs provide more information on the new features in each of the individual programs in the Oasys Suite. They can be found in the Oasys Suite downloads area under documentation. I hope you found that useful and interesting. If anyone has any questions on the material presented or anything related to the Oasys software, Alistair and I are online now, and you can contact us through the question box. You can, of course, contact us at any time through your usual support channels. Please don't forget to join the final Oasys webinar next week. We look forward to seeing you dialed in. Thank you.